This video is just to cover the differences between measurements and calculations, and on this one, this is a lab that we do early in the year in AP Chemistry. It's a pretty good lab to go through and just use to introduce measurements versus calculations. They are marked on this one to make it a little bit easy. I typically don't do that, but I'm going to go down through here and talk about how we know the difference. So on this one, again, you can read the directions there if you want. I'm just going through a little bit of what it is we're doing. We're going to find the mass of a butane lighter. We're going to place that on probably in this case an analytical balance, and we're limited by sig figs by whatever device we use. If it goes to thousandths place, then that's what we're going to write. 10,000ths, that's what we're going to write. I've got a few digital balances that only go to hundredths. We typically wouldn't use them, but if we use something like that for this, then we're going to be limited to hundredths. If we're using an old triple beam balance and maybe it's got markings for every 1/10 of a gram, then we're going to estimate one place beyond. So if it's somewhere between 16.3 and 16.4, then we are going to estimate one place, one level of uncertainty when we do that. Again, AP Chemistry, we typically don't do that. Even first year chemistry, we don't encounter that too much. Occasionally with volumes we will, but definitely not when it comes to masses. We're normally using something digital for that. Final mass of the butane, very, very similar. What we're going to do there, we're going to go through a really similar process. So again, limited by the device that we use. Mass of butane, however, that's a subtraction problem. We got the initial, we got the final. So now we're going to do a decimal chop rule sig fig when we do that. So we're going to do significant digits based on the decimal chop rule. Gas volume in milliliters, a measurement, again, if what we're using goes to whole milliliters, we go to tenths with our level of uncertainty. If it goes to tenths, then we're going to go to hundredths when we're using something like that. Volumes sometimes can be misleading, like for instance a burette. If you're doing a titration and you start at 4.00 milliliters, titrate down to 7.00 milliliters, you've used 3.00. On the other hand, if you start at 0 and go down to 3, you're still going to use 3. In reality, when you start at 0 in a titration, technically the 0 is a measurement, the 3.00 is a measurement. So really when you call that 3, in reality that is a subtraction problem. You're just subtracting 0, so technically it's also a calculation. Again, that's like with a titration lab that we might encounter. So next thing we have is gas volume in liters. That's going to be a conversion, so that's a calculation. So we reflect the sig figs from the value that we convert. Atmospheric pressure, we're going to look that up if we can find it in millimeters of mercury or read it on a device if we can find it. Otherwise, we might have to measure it in inches of mercury, do some sort of conversion into millimeters of mercury, and perhaps even into atmospheres here later on. Room temperature of the water, again, typically with the room temperature of water, typically with room temperature of water, we're going to use some sort of digital device, so we're just limited by the sig figs of the device that we opt to use. Water vapor pressure, that's actually a value that we're going to look up out of a book, so however many significant digits we get with that, that's what we're stuck with. And then we get into a calculation here, partial pressure of the dry butane gas. That's a subtraction problem, so we're going to use those other two values, that atmospheric pressure and the water vapor pressure. We're going to take those, it's a subtraction, so it's a decimal chop rule. And then once we get that value, the next thing is to convert it to atmospheres. Again, a calculation, however many sig figs we have for millimeters of mercury, same thing when we convert that over to atmospheres, weakest link rule there. And then the next thing here that we do is a calculation using PV equals nRT to find the moles, and then ultimately we'll find some other things here, but to find the moles, we're going to be doing multiplication / division, so a weakest link rule when we're doing that calculation. However many, when we go back up through here to the numbers that we plug into that ideal equation, we're looking for which one has the least number of sig figs. Our answer will have the same. Then next step is to find a molar mass of that, where we take the moles and the grams and do a gram to mole division problem. It's a calculation, so you take your grams, divide by your moles. How many sig figs did we have? How many do we have? And then we're going to be limited there by the weakest link. Same thing we're doing percent error. Percent error also has to reflect your level of certainty within your measurements from the lab. So it'll have the same number of sig figs as well. Again, that's just a brief intro to the difference between measurements and calculations with regard to lab activities.